Today's video is on volume. You guys are familiar with volume, you've done volume before, but a quick reminder of volume is, you're going to find volume by multiplying the area of the base and then the height. And so, the idea of volume in most cases for us, we're just multiplying the length times the width times the height. So you guys are very familiar with that. You've seen figures before where you've multiplied the length times the width times the height. The reason I'm sharing this formula with you, volume is equal to capital B times H, is actually really important because up to this point, we've never used capital letters in an expression where we would need to solve, or in this case, an equation. You'll notice there's a capital V and a capital B. The capital V, because it stands for the answer to this question, which is a solved problem to find the volume. The capital B tells me it's the area of the base. So if you think about it, to find the area of this particular figure, you would multiply the length times the width, then you take that answer and multiply it by the height. They're trying to make this equation more efficient by having just two variables representing the area of the base and then multiplying that by the height. This doesn't seem to really matter because in most cases we're finding volume of rectangular prisms. We're just multiplying all three terms, and we can of course use our commutative or associative properties. What this is doing is it's forcing you to find the area of the base first because it's setting you up for future volume problems that you'll be encountering in 7th grade, where maybe you'll find the volume of a triangular prism, where you'd have to find the area of the base, the triangle, and then multiply it by the height. Or even something as finding the volume of a cylinder, where you'd find the volume of, or the area of the base, that circular base, and then multiply it by the height. So that's the only reason we're sharing this formula, is to understand that process. However, for our purposes, we're going to be doing volume of rectangular prisms. Very easy to solve because you're simply multiplying the terms. What I want you to be aware of is, when you look at these images right here, they both look almost like square prisms. You'll notice in this case, they're the exact same picture practically. This one shows 4, 4, and 4, whereas this shows much larger numbers for a very similar picture. We've got to understand that when we're looking at these pictures, our perspective can sometimes be skewed because of the way we're looking at it might not look right to us. Or it could be that it just wasn't drawn well. But what I want you to recognize is that you're always going to trust the numbers. So in this situation where it says 4, 4, and 4, so our base, our height, and our length, our width, and our height are all going to be 4s. To solve this, remember it's volume is equal to length times width times height. We're going to follow that same formula protocol we did in our area unit. So we're going to go ahead and substitute that L for a 4, the W for a 4, and the height for a 4. And so to get our volume, you'd multiply 4 times 4 times 4. Now I know 4 times 4 is 16, and 16 times 4 is 64. Note, because we're finding volume, we're finding out how many cubes fit in this box. This answer is going to be feet cubed. So that we talked about at the beginning of the school year. You'll remember I had a great visual aid on my front board showing the cubes that it takes to make 8 cubic inches. And so in this case, cubic feet, it represents actually 64 cubes would fit in that box, and that's what volume would represent. So this very similar problem right here, we're going to use that same formula. Volume equals length times width times height. And we're going to substitute our length, width, and height. And so 8 times 9 times 7. Now this one's not going to be quite as easy to solve in our head. So 8 times 9 is a basic fact. But 72 times 7, that's not one most people know. We're going to actually have to show our work on that. 72 times 7. So we've got 72 times 7. And here we go. 7 times 7 is 49, plus 1 is 50. What am I doing here? So 504. So 504 meters cubed would be our answer there. So, those numbers are nice and easy, single digit numbers. I want you to notice what I'm going to do here. I'm going to substitute those problems for these problems. And you'll notice that the format is the same. The pictures are actually identical. The only difference is our labels. And like I said before, we're going to trust those labels. So just like before, our formula I'm going to use manuscript letters instead of cursive for this formula now. Length, width, height, which we also could write with the dots, length times width times height. And I'm going to substitute those numbers, 20 times 20 times 20. And I know 20 times 20 is 400. And 400 times 20, 2 times 4 is 8, and then we'll have those 3 zeros there. I get an answer of 8,000 feet cubed. Now when I look at the second example again, it's no different than what I did in the previous problem, except now we are going to be looking at some numbers with double digits, so bigger answer. So length times width times height, we're going to do 16 times 20 times 12. What I've decided to do here is I'm going to go ahead and do this part in my head because I know 2 times 16 is 32 with the 0. And then 320 times 12, that one I'll show my work. I'll stop talking when I multiply this one so I don't mess it up. 2 times 0 is 0, 2 times 2 is 4, 2 times 3 is 6, 1 times 0 is 0, 1 times 2 is 2, 1 times 3 is 3. We're going to add all that up. And we have an answer of 3,840 meters cubed. Now again, that same process that we followed there, it was exactly the same, just larger terms. Which brings me to our real goal for today, is I want us to be able to find the volume of prisms that have fractional edge lengths. And that for some of you might be overwhelming because multiplying fractions can be a little tricky, especially with writing your answers in lowest terms when you're all done. So we're going to do a couple of examples right now. And so our first goal, again, is to recognize we're finding volume of the prism. So we're going to write the formula, length times width times height. We're going to substitute our values, 3/4 times 1/2 times 3/5. Now, I do want to point out that we don't have anything we can do as far as cross-canceling. The 3's don't share any factors on the bottom here. So we're just going to go ahead and multiply across. 3 times 1 is 3, times 3 is 9. And 4 times 2 is 8, and 8 times 5 is 40. The great news here is 9 and 40 share no common factor. So my answer is 9/40 feet cubed. All right, and so now we're going to go ahead and take a look at that second example, and it's also fractional edge length. So length times width times height is 5/6 times 4/5 times 2/3. Now, this problem actually, I almost look at it like it's kind of like fun, because there's a couple of things I can do with this problem that make it a little bit easier, is I can cross cancel. But it's really important to recognize that that cross canceling doesn't have to be just only numbers that are next to each other. So obviously the 5 and the 5, they cancel out. But I can also cancel out the 2 and the 6. So the 2, if I divide that by 2, gives me 1. And the 6, if I divide that by 2, gives me 3. Now I don't have anything else I can cross cancel, even though these 3's are alike. They're both denominators. They can't be cross canceled. So I'm going to do 1 times 4 times 1 to get 4. And I'm going to do 3 times 1 times 3 to get 9. And I'm going to get an answer that cannot be simplified. So I got 4/9 meters cubed. Now if we go back and we had solved that problem without any of that cross canceling, I would have ended up with a number of 5 times 4 is 20, times 2 is 40, and 6 times 5 is 30, times 3 is 90. You'll notice that if I had done it that way, I also could have simplified this by dividing by its greatest common factor to get 4/9. But I will assure you, most of you will be much more comfortable with smaller numbers, so whenever you can cross cancel, I encourage you to do so. As we move to the next level here, this is just showing you the format that we'd like to see you use. You know, we used that, same process when we did our formula protocol when we solved area of figures. And there's a formula protocol when we find volume of figures. So our formula protocol is simply to write the volume is length times width times height. And in this case, your length is 7/8, your width is 1/2, and your height is 5/8. When you're all done solving, you get an answer of 35 over 128 centimeters cubed. So we're following that same protocol, even though it maybe looks different because you're using 3 terms, and because it's not an area formula, it's a volume formula, but there's really no reason why you couldn't do this problem just as comfortably. So I want us to get used to that protocol. So volume equals length times width times height. And our length, width, and height are all 3/2 here. So I'm going to write 3/2, 3/2, 3/2. You can see I'm running out of room on those lines. I'm going to show my work off to the side. 3/2 times 3/2 times 3/2. You can see nothing can be cross-canceled. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. Now we've got an improper fraction. We don't want to leave that. So we're going to go ahead and change this back to a proper fraction. 27 divided by 8 is 3, with 3 left over, and our denominator is 8. So our answer would be 3 3/8 inches cubed. All right, so here's another example very similar, except in this one we've got another added problem, is one of our terms is a mixed number. So when I go ahead and write my formula, length times width times height, to rewrite it and substitute it, I really want to change that to an improper fraction when I set this up. So I'm going to do 1/1 times 4/3 times 1/2. And you can see very simply, I can cross cancel the 4 and the 2. The 4 becomes a 2, the 1 becomes a 1. And I can multiply 1 times 2 times 1 to get 2, and 1 times 3 times 1 to get 3, giving me a final answer of 2/3 feet cubed. Little hint for you, if ever you've got a volume that's got a dimension that's a 1, this is the multiplication property of 1. We could have done this whole problem and just ignored this part and just done 4/3 times 1/2. And you'll notice you'll still get that same answer of 2/3. So be aware of that multiplication property of 1. That certainly will help you. This is the last thing we're going to do to bring this all together, is we're going to take a look at a problem that's missing a dimension. We don't know that value. So we know the width and we know the height, but we don't know the length. So the cool thing here is, because we do know the volume, we can use the equation we know. Volume equals length times width times height. And we're going to put together all the things that we've learned in the last few units. We're going to substitute the values of our variable. So this is an 825. Our length we don't know, so we'll leave that as, I'll leave it as an x, since that's what I'd written there. My width is 15, and my height is 5. Now, we know according to the order of operations, when we've got multiplication, we should go left to right, but we learned that the associative property lets us group these together in whatever order we like. So if we do that, we end up with x times 75 is equal to 825. And we obviously know that x times 75 can be written more efficiently. We can write this as 825 is equal to 75x. Well, if our goal is to find the value of this variable, let's go ahead and solve it algebraically. Let's take a look at 75. Oh man, I wish I hadn't messed that up. 825 is equal to 75x. And we'll isolate our variable by dividing by 75 on this side, and then dividing by 75 over here. Now, obviously, that's not one we're probably going to know in our head, so we'll have to show that work off to the side. So 825 divided by 75. 75 goes into 82 one time with a remainder of 7. Oh, look at how convenient that worked out. And so now we know that 11 is equal to x. And so we can go back to our picture, and we now know our value of x is 11 feet. So you can actually put together all those different skills to get this. Now, this video was a little bit long, and the assignment's a little bit long, but good news for you, this is a 2-day assignment. It's the first one we've had since we've come to phase 3. So you're going to be aware that although this assignment is being assigned today, it actually won't be due until tomorrow. So you can make the decision to do it today, get it done, or you can wait until tomorrow to get it done, and then start to prepare yourself, because we're going to end the week with a quiz on everything with surface area, volume, prisms, and pyramids. So you guys have been doing a great job. Remember, if you have any questions, you know you could reach out to Mr. Gallagher by email, ggollihr @hamiltonps.org. And I appreciate all the effort you're making. Thanks.